Okay, that's a bad introduction. That's awesome. Right, this is a very kind of simple thing. I just wanted to go through it as one little added thing that you probably haven't considered before, haven't been told before. So we're talking composite functions. Okay, you've done this before in your IGCSEs. So a composite function is where we talked about it briefly yesterday. Last lesson, was that yesterday? Where you've got one function is applied to another one, and we talked about it in terms of differentiation. But just notation here that you have to be aware of. It's funny because in the books it says this and then uses another one. We've got fg of x, lots of brackets. We've got fg of x with just the brackets around the x. We've got f of g of x with a little o in the middle. They all mean the same thing. So just to rattle through these questions then, we've been told that f of x is x squared and g of x is x minus 3. Find f of g of 1. How do we do it?
Plug in 1 to g of x.
Okay, so we do g of 1, which equals minus 2. And then we do f of minus 2, which equals 4. Okay, and that's your answer. All right, what is fg of x, though?
X minus 3.
So we've got x minus 3.
And then
plug that into x squared. We were talking about this yesterday. So it becomes x minus 3 squared.
Yeah.
Comes that. G f of x.
Squared, then plug it into
X squared, then that becomes the x in g of x, which is just x squared minus 3. Okay. Pretty basic stuff you've done before. All right. The bit, there's a couple more. So f of x can be written as f squared of x. Okay, it doesn't mean you're squaring it though. That's the thing. It means you're doing it twice. So given that f of x is 2 over x minus 3, how do we find f squared of x?
plug in 2 over x.
Go for it. You do it. I'll pause. You guys can do it. Remember what it means when you apply a function to a function. This function becomes the x in the outside function. All right, so imagine I put that in brackets and then put it is x in itself. So it becomes 2 over, and I'll write it again, 2 over x minus 3 minus 3. Okay.
Did something, but I'm not sure it's right. Do you know that?
I do know the answer.
Is it minus 4 over 3x plus 4?
No. Although, no, I don't think so. I don't think that's even equivalent to what they've got.
Okay.
What you're looking at there, guys, is a fraction with another fraction in. So we're dealing with fractions. So probably let's deal with the fraction bit first. So 2 over x minus 3.
Is it minus 2x plus 3?
What? That's the final answer. We'll get there.
Okay.
So how would I do this? I'm going to simplify this. So this is going to become 3 times x minus 3 over x minus 3. All right, so I can make the same denominators. What does that then become? Becomes
Minus 3x plus 6.
2 minus 3x plus 9 over x minus 3. Now when you've got
It's just 2x.
this sign, so obviously you divide by a fraction, you can multiply by the reciprocal of the fraction. So we've actually then got 2 times that x minus 3 on the bottom here, over, simplify that a bit, so 2 and 9 is 11 minus 3x, which 2x minus 6 over 11 minus 3x.
Yeah, no, I was
Yeah.
wrong. I just forgot to times the 3 by x minus 3 as well to get rid of them.
Okay. The next thing is probably the difference thing, which is for a composite function f of g of x to exist, the range of g must lie entirely within the domain of f. Otherwise, you would be trying to put values into f that it cannot take. Does that make sense?
No.
No? Okay. I know you might be right. I'll pause and let you write that down before we discuss it and explain to some extent. So I'm going to go back up to this point here. All right. And here, look, this is going to kind of be my attempt to explain, which is we put the number 1 into g of x, yeah? And we got a value of minus 2 out. All right. Now, this number is part of the domain of g of x, yeah? This number is what?
The range of
The range
or
of g of x.
Okay.
Part of the range. Okay. Now, what we're saying then is that the range of g of x becomes the domain of f of x.
Yep.
All right. And then obviously the final answer is the range of f of g of x. All right. Now, where would a problem potentially occur?
if it's 1 over x,
Why?
because you can't divide by 0.
But you have to give me some
The
details.
range of g of x is 0.
Okay. So if this number being put into that position, this one's no problem, right? Absolutely no issue. But there could be, like you say, depending on what type of function it is, if I stick something in here into g of x, it will produce a perfectly valid answer for the range of g of x, but that has to be a valid member of the domain of f of x for it to be a valid composite function. Okay, so like you're already saying, there's obviously going to be some functions where the output of the first function means that the second function can't work. All right. So, having a look then at worked example 2.10, the functions f and g are defined by f of x equals x squared minus 5, where x can be any real number. Okay, all of that's one bit. And then in another colour, g of x is the square root of x plus 3, but x has to be greater than or equal to negative 3.
Yeah.
Why is that true for a
If
start?
it's negative, it's not a real number.
Okay, so you've not got any real values. So explain why the composite function gf is not defined.
Because of what I just said.
Or give me a specific.
For example, if you input 0 into this is GF of x.
So it's
Yeah.
gf of x. So
If
you're
you
going to
input
do
0
f of 0 will
minus
equal
five.
minus 5. Okay. and then g of
minus 5.
-5
Square root of
will
negative
give
2.
you the square root of -2, which is
Not real.
not real. Okay, and that's it. That's all we're looking for in that case. So, what's the problem then, or how could we overcome this problem?
Use a measure.
Yeah, potentially.
Does
The focus actually is here
change
now.
the range?
Yeah, well, change the domain of the original
Right.
function. Yeah, so the domain of the original function is what is the problem. All right, so we need to adjust that domain. So where it says find the largest possible domain for which g of f is defined, in this case, state the range of gf of x. So first of all, state what the largest possible domain is for that situation. I'll pause, let you think about it.
Like -1 to 1.
Well, as Luke said, basically, if you look at the function there, we've got the initial function is x squared minus 5. The domain of g of x is this. So what we're saying is the domain needs to be the range of this one, doesn't it?
Yeah.
So the range of this one becomes the domain of the next one. And we know what we want as the domain of the other one. So we're trying to limit the range of the initial function. So we're going to say that x squared minus 5 must be greater than or equal to 3. So what values of x can I use? So basically I'm limiting my range, aren't I, to being this is these are the range values.
Minus 3.
So we're going to have x squared must be greater than or equal to 2. Therefore, x must be greater than or equal to root 2.
Is it -3? The range of the first one.
Right.
Square -5 is.
Sorry, hang on. Okay, gentlemen, I want you to consider what I've written here, because obviously we have to be very careful with inequalities, don't we?
Why? Because it's irrational.
Eh?
Why?
Well, we've just said that x squared must be greater than or equal to 2, and then we've just said x must be greater than the square root of 2. However,
Plus or minus.
plus and minus, isn't it?
Yeah.
But that's going to impact your inequalities. Because if I just said, well, x must be greater than or equal to square root of 2, and also x must be greater than or equal to minus the square root of 2.
Yeah, do we just have to? No. It's greater than minus root 2, but less than root 2.
No, opposite.
So it's going to be the other way round, isn't it?
Right.
Which one?
The negative.
Okay. Yeah, this sign here is the problem, isn't it? We actually want x will be less than. Why is that the case? Because obviously when we square it, it becomes positive, which is the same result. So we actually want things to be more and more negative, because when we square them, they become more positive, which is what we're after. Okay, so we now have specified domain for my initial function. We're saying the domain is x must be greater than or equal to square root of 2, x must be less than or equal to minus the square root of 2. Okay, what will then be the range of gf of x if this is the domain to start with?
Just plug in root 2. Yeah.
Go for it. So if we state that the domain now, so instead of this, we've now crossed this out, and we're saying that instead of that, we've now got x must be less than or equal to that, or x must be greater than or equal to this. These numbers now need to go into here, that then go into here. So that obviously limits my final answers. That's the range that could possibly come out. So what's the range of values that I could end up?
0.
Zero or larger.
Yeah. So we've got the range of GF of X is going to be anything greater than or equal to 0. And that makes sense, doesn't it? Because when we were looking at this, obviously we were looking anything that made this negative was a problem, but anything 0 and above was going to be fine. So therefore, the square root of 0 is the smallest value we're going to have, which is 0. The square root of 0. I'm going to have an x value that makes this no smaller than 0, right? Otherwise it becomes a problem. So which number would give me
-3.
0? -3. And that falls within this, yeah? X would be less than minus square root of 2. So -3 falls within that part of the domain. So I put that. So I get that -3 would make that 0. But then -4 would make this. Put -4 in, we would get a different number, which would make this go more positive, wouldn't it?
Yeah.
So that means that my range is going to be g of f. The range of gf of x will be greater than or equal to 0. Okay. All right. Yes.
How does it work out? X is smaller than minus root of 2 and larger than...
So remember what we're doing. So let's go back to this stage. So we put in f of 0 is -5. 0 is between these, yeah? So basically, if I were to do a number line, what would my number line look like? I'd have a solid dot there and a solid dot there, and we're saying x must be greater than the square root of 2, but it must be less than or equal to negative the square root of 2. So if I put, so I'm saying I'm allowed to use any of these values. Where does 0 fall?
Between them.
Between them. That would be 0. So that's a part of the domain I'm not allowed to use.
Okay.
Right? If I put 1 in, where would 1 be? In there or outside?
In there.
In there. Why? Because square root of 2 is a bra.
1.8. Something.
1.4.
1.414213.
So 1 would be again in the domain that I'm not allowed. So if I were to pick a value of 5, that would be fine, yeah? And let's just show that that works. So if I did f of 5, I get the answer 25 minus 5 is 20. Then I do g of 20. I get the square root of 23, which is fine. Okay. So that's basically what we're saying. And if I put a negative value in, let's do -7, for instance. F of -7 is going to be 49 minus 5 is 44, and then we do g of 44, which is the square root of 47, which again is fine. Okay. All right. Little problem solving one for you now. I'm not pre-prepared, having written down, but worked example 2.11. So we've got if f. I should pause. Yeah, so basically we've been told that this transformation has already happened. Yeah. So we're trying to figure out what it was to start with. So basically trying to unpick a composite function. Over to you. See what you can come up with. I go through the efficient method. You can compare. Obviously, we've got a couple. You've got a right answer as well.
Yeah.
Yours looks a lot quicker. Okay, so basically, what we're saying is that when we do f of x plus 1, we're putting x plus 1 into a function, all right, and ending up with this one, yeah? So the x plus 1 is the y value. Understand the input, the output thing like we were talking about? To go into the next function. Yeah? Remember what I was saying, the domain of the first function becomes the range of the first function becomes the domain of the second function. So the way we can look at this is to say, well, if I put x plus 1 into the initial function, that becomes the y value. All right? And then this y goes in, but we're going to do a rearrangement and say, well, x is equal to y minus 1.
Yeah.
And then I'm just going to do 4 times y minus 1 squared plus y minus 1. Yeah? All right? And then obviously you just expand that. So what does that become? 4 times y squared minus 2y plus 1 plus y minus 1. So we've got 4y squared minus 8y, but plus a y gives me minus 7y. 4 times 4, but minus 1 is plus 3. Okay. But then obviously being a function in its own right, it's going to be, we swap the x and y. 4x squared minus 7x plus 3. Okay. So nice, efficient, mate. But you guys got to it different way. Shows you there's some understanding there. What about you guys over there?
They got it.
So just to remind you of binomial expansion, we've done this. I mean, what I'm saying, we're really rattling through because trying to get as much stuff done for you before the end of the year. So we did all this. Okay, so all this. But how would you, so sort of combining, but not completely, don't think, oh, I can do everything I've just done with composite functions with this. So a binomial expansion of compound expressions, what would you do if you were given the square root of 1 plus x over 1 minus x?
I don't know. I'll try and rearrange it.
Say it again.
Square it.
Well, if I square it, I'm changing it because I've not got an equals something
I would
to balance it out on the other side.
1 plus x times 1 minus x to the power minus 1.
Okay. So first thing is to write it in a form where we can actually do an expansion. So we're going to have 1 plus x will be square rooted over 1 minus x will also be square rooted using the laws of surds. And then we've got, this becomes 1 plus x to the power of a half over 1 minus x to the power of a half. But then that becomes 1 plus x to the power of a half times 1 minus x to the power of negative a half. Okay, so what do we now do at this stage? So we want the quadratic term, which basically is just the which term? So the x squared term. All right, we want the x squared term. Now, but here's the thing with this. What we'll need to do is both of these are separate expansions in their own right, aren't they?
Yeah.
So we'll then have to multiply them together and we'll end up with a range of terms, and we only want the quadratic ones.
Okay.
All right. So it's not This is why we're only being asked for one term, the quadratic, because obviously both of these in their own right will give you infinite
Yeah.
series. So what's the first one?
1 plus
N
half
to the-
x
1 plus a half x
Would it?
plus half
plus a half.
bracket minus 1
So minus a half
over 2 factorial
over 2 factorial
x squared.
x squared.
Is
Plus, do we need to go any further than
No.
that?
is that x or is it x to the power of?
It's x.
Okay.
Yeah. The only time this x changes
If
is
it's
if I've got
inside of it.
something with that. Yeah.
Okay.
What's the other one?
1 plus half.
1
Oh no, it's negative a half.
minus a half times minus x.
Minus.
Okay.
Plus
Plus
minus
minus a half times
minus 3 over 2
minus 3 over 2
over 2
over 2 fact. Let's do it, don't I? Question mark. 2 factorial x. Well, actually, I can just do x squared because minus x squared is the same thing.
Okay.
Okay.
It's 3 over 2.
minus half minus.
Remember, it was n and then n minus 1. Yeah. If n is minus a half, minus a half minus 1
Oh, yeah.
is. Okay. All right. Where do the quadratic terms come from? So we're going to have to multiply these together. So obviously 1 times 1 is just, okay, we don't need to worry about that. But 1 times this one would give me,
Let's see.
so this is a half minus 3 over 2, so that's going to be, is that
3.
2? So minus 4 over 2?
Yeah.
Oh, yeah?
Or just.
It's
4 over
just
2.
2?
Yeah.
Yeah?
Yeah. Over 2.
2x squared over 2 is just x squared. So there's 1x squared. Okay. Four over 2.
Oh no.
Oh, no,
yeah, it's
it's
3.
not. No,
It's
you're
3
right.
over 2.
Yeah, it's not because I'm adding there, isn't it? What is it? It's
3.
It's 3 over 4, isn't it?
Yeah.
3 over 4. Okay. Yeah, sorry, I'm thinking about it. So we have an x squared term. Is there another x squared term? Well, yes.
Yes.
We've obviously got 1/2 times minus a half times minus x. Well, that's just plus half x. So half x times half x is quarter x squared. So we've got another one there. And then we've also got
1 times.
x squared times 1 is, well, this
Minus
is half times
quarter
minus a half is minus 1 over 4 x squared over 2 factorial.
Yep.
Yeah? Any other quadratic terms involved?
You forgot the minus.
Yes.
Which is.
Is that all of them? And
3
so that one's with that one, this one's with that,
plus
this was with that. I think that's it, isn't it?
2 minus 3. So it's just
1 over 8 plus
1/2 x squared.
I can let you simplify all that for yourselves, but all I want to go, the idea is that just like with your other simpler expansions, when you have to find a term in like x squared, it's not as simple as I just need the x squared terms and I'm just going to, you know, because obviously this is a multiply of 2. So I will end up with 3 separate, I mean, I've done that quite quickly, tried to, there might even be mistakes in there, but you'll double check it. So that's all good. All right. So that would give us our quadratic term. All right. When we've simplified that up. Okay. So a couple of things there we've looked at. composite functions should be quite basic from before. What's the one probably new thing that we've done with composite functions?
The domain and range values.
So the domain and range thing was. So what's the important thing with domain and range stuff?
They
So-
must be valid.
Entirely domain.
Yeah. So we've now got a situation which you didn't have at IGCSE, where some of these composite functions are not actually valid functions, because you didn't really have to worry about domain and range and stuff at IGCSE. Now you do. Now you're going, oh, I can't just chuck any number in. All right. So it's only valid for certain domains to start with. We also did however, you guys did it a different way. We found the initial function if we know it's been worked on in the past. And then, obviously, in a similar connected way, but not completely connected, different, you've also looked at, well, what happens if you have one of these compound functions and you're having to do an expansion. All right. Don't forget, this is quite a simple one in the case that it's already of the form 1 plus x. If you had to sort that out as well, that's going to make it even more complicated. So lots of work to do there. All right.